In this tutorial, we're going to learn how to name substituents and how to integrate the name in chemical compounds. In the previous compound we saw, we have seen that it has 9 carbons in the parent chain, so the name will be nonane, and we have also identified substituents. Let's now name substituents. So if we have 1 carbon, the name will be meth, and it's going to have the suffix il, while if we have 2 carbons, the name will be eth, and it's going to have also the suffix il. How we name now the compound? The second rule we will learn says that we have to number the parent chain in a way that we will assign the lowest number to the substituent. That means that if I start from the top and I give it number 1, then the first substituent I meet is in number 3, while if I start from the bottom as 1, the first substituents that I meet are in number 4. Number 3 is lowest, so this is gonna be the correct numbering of that compound. So let's erase the previous and let's name now the compound. We see here that we have a methyl group in number 3, an ethyl group in number 4, and another ethyl group in number 6. How we name now the compound? It will depend on the substituent we have. Here we have ethyl and methyl. Ethyl starts first as in the alphabet, so we're gonna start with ethyl and we have to define the position. So this is gonna be 4, 6. Here I have ethyl groups, and because I have 2 ethyl groups, I'm gonna write diethyl. Then I'm gonna add the methyl group, which is in position number 3, and of course the name of the parent chain, which is gonna be nonane. So this one is gonna be the name of our compound. Let's see the second example, which is easier. In that case, we see that we only have 1 substituent, and if I start numbering from the bottom, we see that we have this substituent in number 5, while if I start from the top, we see that we have the substituent also in number 5. So in that case, we saw a symmetric structure, and let's name it. In that case, we're gonna have the substituent is a propyl group because we have 3 carbons. It is in number 4, so the name of that compound is gonna be 5 propyl nonane. Let's see now how we name structures that have the same number of carbons but have different substitution. In the structure we have on the left, we have 10 carbons in the parent chain and 4 substituents, while in the one on the right we have again the same number of carbons but we have only 2 substituents. In that case, the rule says that the correct structure will be the one that has the highest number of substitution, which means that one in our case. How we name it now? We see that we have a methyl group in number 2, another methyl group in number 4, and we have a butyl group in number 5 and an ethyl group in number 6. Between methyl, butyl, and ethyl, butyl comes first, so the name of that compound will be 5 butyl. Then we go to ethyl, which is number 6, and then we go to the two methyl groups, which are position number 2 and 4, and because we have two methyl, I'm gonna write dimethyl, and of course the name of the parent chain, which is decane. Let's go now in the next example, where we have let's start from the left compound, where we have here substitution with three methyl groups. And here I want to remind you that we have to number the parent chain by assigning the lowest number to the substituent. But we see that if we start from the left and we give it number 1, number 2 is going to be the methyl. But the same will happen if I will start from the right. In number 2 I'm going to have the methyl. In that case that I have a substituent in the same position, the first substituent in the same position, I'm trying to assign the lowest number to the second substituent, and I see that if I number it from the right, the second methyl group comes in position number 3. So this is gonna be the correct naming. Okay, so in that case the name will be, I have methyl groups in 2, 3, 4, 5, 6. So the name here gonna be 2, 3, 6, trimethyl, because I have 3 methyl groups, and I have 1, 2, 3, 4, 5, 6, 7. So it's gonna be heptane. While in the structure I have on the right, okay, here I only have two substituents. Again, I'm gonna number the parent chain by assigning the lowest number to the substituent. I see that if I start from the left, I'm gonna have the substituent to be number 3, while if I start from the right, the substituent will be number 4. So this is gonna be the correct structure. And how we name this, it's gonna be 3, 4 dimethyl, because I have two methyl groups and I have here 1, 2, 3, 4, 5, 6, 7. Similarly, it's gonna be heptane. In the case we have now cyclic structure with substituents, we have again to assign the lowest number to the substituent. In the compound we have on the top, if we assign number 1 to this carbon, the other one will be number 3, while in the opposite case that one will be number 1 and that one will be number 3. However, we see that here we have a second substitution, so that's gonna be the correct structure. And let's name it now. We see that we have 3 methyl groups, so in that case it's gonna be 1, 1, 3 trimethyl, cyclohexane, and let's now name the compounds in the bottom. On the bottom left we see that we have 6 carbons in the parent chain, while the substitution has 2 carbons. So the name in that case is going to be ethyl cyclohexane, while in the Other case, we see that we have 1, 2, 3, 4, 5, 6 carbons as the parent chain. Okay, we see substitution in number 1 because the cyclopropane is a substituent in that case because it has a lower number of carbons. This is going to be the substituent, and we name this compound cyclopropyl hexane. And don't forget that this is in number 1, so we need to add 1 cyclopropyl hexane. In the next tutorial, we're going to see more complex substituents and how we name them.